everyone. Egis is operating in 100 countries today. He is ranked at the 7th international leader player in the transport market by the Engineering News Record in 2024. Our group is an international player active with a multi-expertise approach, including consulting, architecture, engineering, and mobility services. As a key player in the transport market and design and construction of railway projects, in the support of operation and maintenance, network modernization, automation, infrastructure resilience, our group supports a wide range of projects, from high-speed lines to urban metro networks, including intercity, transport solution, and complex rail infrastructure. Among these subjects, we choose today 3. With my colleagues here, we will discuss digital engineering in the world of transportation by Anthony Derderian, Marketing and Sales Manager for Digital Offer at Egis, the automation and the modernization of metro lines already in operation with Ludovic Morel, Egis Project Director for the automation of Lyon France Metro B, and finally, the management of technical risk in the construction of underground structures with Vincent Rainot, Project Director and Tunnel Sales Manager. Anthony, the floor is yours.
Thank you. Thank you very much. Hello, everyone. I'm really pleased to be here with you at Innotrans 2024. My name is Anthony Derderian, and I'm in charge, like we said, of digital solutions for Egis Group. I'm going to speak about the acceleration of digitalization of the architecture, engineering, construction, and operation industry, and how a leader as Egis wants to catch these new opportunities. We have realized a study of our AEC and O&M sector and saw an acceleration of the digitalization without a strong digital maturity. The first step concerns the optimization of internal processes, a digitalization of our way to work. The second step is about the value chain transformation and improve a part of a job. After that, we can see a partial disruption with new business models and new value territories. Finally, we could have a strong disruption with new players on our market and disappearance of historical players. So we know that digitalization is under progress, and the question is how and when our sector will be disrupted. Since 2005, we can see different steps of maturity with the BIM emergence and other information systems. From 2020, we have an acceleration due to recent changes around the world to increase a kind of digital maturity today. But how the future will be and when will the next acceleration? Data management capabilities and new AI solutions drive it. Lots of technologies have emerged, but just some of them are really deployed to be done. We have a combination of cloud capacity to host a lot of data, some tools to catch information, and finally, some solutions modeling and make simulation. These technologies are strong now, and the main challenge is to define the value-creating use cases. We are going to see the Egis approach about digital solutions and AI. Egis has been working for 4 years to prepare for changes in our ecosystem and has selected 3 major topics to build our portfolio project. We are focusing on the gain efficiency to give more tools and improve the way of work day to day. We are defining new services for our clients and support their digital transformation. We are maintaining our leadership on regulatory framework at international level with cooperative projects. We have now 3 teams of specialists to facilitate and support our project. Data Factory to work on data management solutions, close to our clients across the world. Digital Factory now to design, developing and operating application in response to clients' needs. AI team to finish, to lead our ambitious AI program represented by David Gay here alongside me. To lead digitalization process of our clients, we can now support them from strategic to operational level, with lots of people which knows both of AEC and O&M sectors and digital issue for sure. An example with Act for Eco-Design, like our capacity to define, design, develop and operate a digital solution to provide for every Egis project manager a diagnostic tool to identify the most significant environmental aspects of their project regarding biodiversity, soil, pollution, carbon, resource management, reuse, and material adaptation to climate change. Other concrete solution, Connect Twin by Egis. And I'm really pleased to give you today this preview of our next launch. For 3 years, Egis Group has worked on some digital twins projects alongside with our clients for sure. Today we have a dedicated offering to identify clients' needs, deploy its twin and bring its twin alive. As you can see, this small QR code, we can explore a lot of content directly by this way. But before that, I share with you our commitment about Connect Twin by Egis, focused on UX, user experience before the specialist or technology. Progressive to start with a relevant scope and progress after that. Modularity to connecting existing solutions to new components like 3D, business information, simulators. Sustainability to promote open technologies and lower energy. Synchronization to connect twin the digital twin to the real world for greater confidence. So, as I said, we have already some success stories, like in Marseille for the extension of the tramway. The Twin City and its underground networks, modeled by digital twin, promote eco-design, make construction safe, and improve the operability of the northern and southern extension of tramway. In Brisbane now, for the M3 Inner City bypass, the digital twin of the urban roads improves the safety and efficiency of 15 kilometers of tunnel by putting the use of point clouds at the heart of their operation. Just near in Canada, within a nuclear power plant, the digital twin created with the support of Egis will facilitate the operation of one of the world's largest nuclear power plants, built in the 80s for the next 40 years. And finally, Gyros, the digital twin of Europe's largest estuary, integrated by Egis, assesses the navigability and accessibility of the port of Bordeaux in the light of climate forecast in 2050. So, to conclude my word on an overview of a digital journey within Egis, an opening of our AI program. First, it's important to consider our work with employees and clients' expectation. So we have worked with them to define business cases, identify if and where data input are available, and how we could implement those. 3 families are covering almost first needs and specificities: document-centered, mock-up and sketches, asset management and site supervision. With document-centered family, we have an elementary brick and 10 business-oriented use cases to build finally Iris our AI one-stop shop gathering different use cases based on Egis jobs. The mock-up now and sketches use cases are mainly intended for Egis architect, technician, and engineer. The benefits are to be found at the crossroads of our technical expertise and our knowledge AI. And finally, the asset management and site supervision use case provide a link between our mission in the field and our back office mission. They concern both Egis engineering and operation staff. So, as you have seen, a lot of transformation are operating in our industry at Egis, and Egis is ready to reach these challenges. Thanks for your attention.
Thank you, Anthony. I have a question. Digitalization has a significant impact on the transportation today. So what are the short-term benefits for you?
Yeah. In the short term, the benefits of digitalization are very much oriented to asset management and passenger flow optimization. On the short term, we could develop short benefits, the whole stock benefits of a kind of predictive maintenance for passengers. Digitalizations will make it possible to regulate the traffic of multimodal flows and give orientation towards the available means of transport.
Wow, impressive. Thank you.
Thanks.
Digitalization is transforming transportation, also with the automation of metro lines. Ludovic, can you please tell us more?
Sorry. Good afternoon. Thank you for attending this presentation, and thanks to our customer, Citral Mobilité, acting as transport authority in the Lyon area and project owner of the project I'm going to present you. Well, let's talk about automatic metros, and more precisely about driverless automation of existing metro lines, with the example of Lyon Line B operation. I will not try to summarize this project within 15 minutes, but my purpose is to give you a brief picture of stakes and impacts of such an automation on existing lines, with the example of Lyon Metro Line B, the project I'm managing within Egis. So first of all, a quick overview of the Lyon Metro network. We have also buses, tramways, and trolleybuses, but not shown on this picture. 4 metro lines from A to D. Line A and Line B have been put in operation in 1978. That means almost 50 years ago. Egis was already at the origin of this line, performing the design and the management of construction work, testing and commissioning. Line C, the yellow one, is quite unusual, a short one, but quite unusual because it is a rack railway due to steep slope of almost 18% on a former funicular route. Line D, the green one, has been put in operation in the 90s. It's already fully automated, driverless. It's the first large-gauge metro line in the world, as well with an Egis EPC management. A, B, and D lines are rubber-tired rolling stock, such as in Santiago de Chile, Mexico, Montreal, Paris, or Marseille. These lines, as you can see on the presentation, have been already extended several times. The last one, the last extension is the southern extension of the line B, has been put in operation in October 2023 last year, with 2 additional stations. So today we are talking about specifically of line B, the blue one, from here to here. Something which is important to notice is that the workshop of this line is located at the eastern part of the A line. So it's a common workshop. That means that drivers come with the train set from the workshop to the beginning of the line B. The driver goes out from the train set, switches it in driverless mode, leaves the train, people get on board, and the train leaves driverless. The other issue I will talk about later is this dot line, black one. It's a connecting tunnel between line B and line D, which was not really used. And we decided, in order to avoid many movements of empty train set to the depot, we decided to adapt this connecting tunnel to be able to make some storage of rolling stock. Even if today I will talk about line B, the operation deals with 2 main objectives, larger than line B. The first one is to cope with traffic increase on lines A, B, and D. So that's the first reason for the automation of line B. And also the upgrade of the subsystem of the network. Remember that the A and B lines are almost 50 years old, and they need constant obsolescence management. Line B is about automation. We will develop this topic and replacement of rolling stock. Line D deals with replacement of actual CBTC. As I said, it's already driverless since the 90s. So it's about 30 years old technology. And line A is about strengthening the transport capacity through the transfer of previous line B rolling stock, which is the same than line A. So it will provide additional rolling stock in order to cope with traffic demand. So the first message I would like to give you today is that automating an existing metro line is not only a matter of CBTC or rolling stock. It's also a global infrastructure and system concern. This is why a company such as Egis is necessary to manage all these interfaces and to manage the transport system integration from the very beginning of the studies, then during construction work, until testing and commissioning. This is the Egis expertise. For example, we performed modifications on power supply installations in order to cope with the new and additional rolling stock, but also to manage replacements of old equipment, such as cables and cabinets and so on. We manage evolution of the operating control center with up-to-date systems in order for the operator staff to manage the driverless metro operation with new screen walls, CCTV, and so on. As I said, the workshop is very far from the line and very far from the southern part of the line. That's why we decided to put a washing machine for the trains in the tunnel, which is completely operated remotely from the OCC without any people on board. Another example on the next slide, we performed some track works We made some works on the low voltage systems, for instance, on passenger information, on communication, CCTV. And the connecting tunnel I talked to you about a few minutes ago is this one, a narrow one, but you can see here two train sets which are stored with fire detection, fire extinguishing system, lighting, etc., and so on. The last topic, depot extension, due to new train sets, additional train sets, and also because these train sets have now HVAC system on the roof, 2 additional tracks have been put in place with equipment allowing to access on the roof. I would like to take this opportunity to emphasize the fact that in Lyon we have now 2 driverless lines, but without any platform screen doors. The system on lines B and D is an infrared detection systems with beams which detects if someone falls on the track and then switch off immediately the power supply, the 3rd rail which is located here, and also apply emergency braking on the rolling stock, on the train sets which are in the area. This technology has been deployed on line D at the beginning of the 90s. So there has been a huge work of reverse engineering in order to be able to deploy this system for additional decades for the operation of line B. Sorry. Okay. I thought I had some. Okay. Before getting into details on the impacts, just a few milestones on this project. Egis started its studies in 2015. The first train set has been delivered 4 years later, in 2019, and the revenue service has started mid-22. That means roughly 7 years after the beginning of our studies. But just keep in mind that this kind of project is roughly 10 years long. It depends, of course, of the length of the line, etc., but it's roughly 10 years long. So now let's talk about the main challenges we had to cope with during this operation. The first one, the survey of existing installation. It is necessary to get a good picture of the system you are going to work on. Do not hesitate to spend time on this activity, this phase, in order to avoid any bad surprises later, because during decades, of course, the line has evolved and the systems also, and you have to make sure that the as-built documentation is consistent with what is on site. The second issue is an issue about managing the construction works on this existing line. The line is in operation, so you have to work at night. Service interruption is quite short, about 3-4 hours maximum. So that means you have to work many nights. Sometimes you have to manage some adaptations of the operation. So we had to work in close cooperation with the operator. For instance, to give you some figures, for the automation of the line B, we spent roughly 1,500 nights of works, which represent approximately 7,000 hours of works at night. That means there are also additional work, but during the day, without impacts on the operation. But we had to work at night 7,000 hours because these works had an impact on the operation. And also, in addition to the construction work, of course, we do not forget the maintenance work, because the operator and maintainer has to maintain the line in order to operate it correctly during the day. Third point, the migration strategy. You start from a system with drivers, and you want to go to a system without any driver. One way to deal with it is to make it with what we call a big bang. That means from a day to the following, you change everything, you switch, and you bring the new rolling stock, and you start with the new system. On Line B in Lyon, sorry, we decided to act differently. We started with a revenue service first on Sunday. And then on Monday, we went back to the previous one for the entire week. And then the following Sunday, back to the new system. Then during all the weekend, Saturday, Sunday, and after a given period of observation, we decided to put it in operation all week long. This enables a smoother progressivity and a better return of experience before entering into a full driverless service all day. The fourth issue is related to the switch between the previous configuration to the second one, to the final one. As I said, we switch sometimes on Sunday on the future system to the previous one. So we have to, in that case, you have to remove all the old trains, bring the other one, the new one, switch all the IT systems, and it can be quite long. It can take several hours. Specifically, if you have many trains to put on the line, it takes more time. So, in this case, there is no other possibility than closing the line 1 day, 2 days, maybe sometimes 1 week, because we cannot do it during a short night. Fifth is the operator training. As it is an existing line, the operator, all the staff, is already acting and operating the line. So they don't have a lot of time to spend on this training on the new system. There are many people to be trained, so you can be, so you could be, you would like to start quite early by anticipating. But by anticipating too much, you can be in a situation where the system is not good enough, not mature enough to start the training. So we had to find the good balance between the maturity of the system and the time we had in front of us before the commercial service. So this needs a close cooperation and management with the operator and an efficient schedule management from Egis. Sixth is the overall testing, trial run. That means all the works have been made. We have to test the system. And of course, once again, there is no other solution than closing the line to perform the major testing. For instance, when we made the extension of the Line B, 2 additional stations, 2.5 kilometers, we had to close the Line B during 35 days during the year. not 35 days altogether, but different periods. And it takes time, of course. There is an impact on passengers, but it's necessary to close the line. This was for the extension. For the automation of the line, as we could not close the line too long, we decided to perform the trial run divided in different closing periods. So that means every Sunday until roughly 1 p.m. The line was closed, and during several months we closed the line to perform this trial run and to allow the operator to get familiar to the system. Seventh, the functional growth. Such an operation is very complex, very, very complex, and it's impossible to imagine to get 100% of the functional scope of work at the same time, the first day. That means you need to think about the roadmap, which will bring you from the beginning to the final system. So you have to have a clear roadmap of the functional growth, including also, of course, some capabilities of corrective software baseline. And the last one, dismantling, is the final step. Once you put in operation the new system, you have to remove the old one, not only because they are not useful anymore, but because you have to free some space for future evolution, to put additional cables, to put additional cabinets, because the owner has to maintain and evolve the network, and so they need this space. So we have to manage the dismantling. This is a sensitive issue because it's very easy to create some problem when removing a cable which is not the good one. And this is directly linked to the first step. The loop is closed because if you have a good survey, you will have a better dismantling. And in order to conclude, last but not least, something which is probably the keystone of any project, not a technical one, this is the teamwork. And we want to focus on that because without any teamwork, there is no success. And this is some pictures of what Egis performed on this operation. Thank you.
Thank you, Ludovic. Do you have any questions? Yes, please.
Yes, hello. I would like to know how many people were involved into this project?
Plenty of them. Some, on the consortium side, the peak mobilization was probably, for the automation, was probably roughly 40 to 50 people. Just for the automation. I'm not talking about the extension. For the extension, it's additional people. But on the EPC consortium side, we managed, it was roughly 40, 50 people. But of course, there are a lot of people from the companies which perform the site works. So it's hundreds and hundreds and hundreds of people with the companies, the suppliers, the sub-suppliers, and I think we could say of several thousand of people.
I have a question for you, Ludovic. You mentioned the technical aspect of this automation of the line, but I imagine there's a global approach involving coordination and interaction with various stakeholders on the project.
Yes, indeed. As you see, there are many people, many stakeholders. First of them is our customer, Citral Mobilité. the owner. Of course, I talked about the operator, the maintainer, Keolis, the safety authority, STRMTG, and also all the companies involved in this project, roughly 30 companies directly from rank 1, directly involved on this project, and as I said, many suppliers, and so on. So it's a very big project.
Thank you.
Thank you.
So we discussed the concept of safety with Ludovic and the risk associated with the metro automation. Now let's address the risk related to the underground construction. Vincent, please.
Good afternoon, and thank you for attending this presentation. So we'll now talk about the construction of tunnels before automating lines when they are operated, and especially focus on the risks related to this construction. First, some generalities on geomechanical investigations. We'll then present you shortly the Moncenis-based tunnel, and then the main point is how we reached from the excavation of the main tunnel from the first investigations, and we will conclude with a few perspectives. Just a word about long tunnels in mountainous areas. We just talked about a metro operation in a city where the geology is really rather regular. Here in mountains, coming from powerful tectonic movements, the geology is more complicated, very complex, numerous faults, crushed ground, multiple formations, as you can see here on the geological profile from the French Alps. And we have a risk of significant convergence, as we are going to see later on. Tunnels construction includes numerous risks that must be mitigated insofar as possible by several measures, provision and procedures during design and construction phases. Major risks are related to geology and geotechnical conditions, high stresses, temperature conditions, and at the portals, geomorphology, landslide, avalanches. Risks have potential impacts in terms of investment costs, construction deadline, or even the feasibility if they are not mitigated when beforehand, and if no measures are taken when it's necessary to take them. And then investigations are essential to identify and evaluate the risks and to plan, anticipate, and manage them. The main objectives of the investigations are to collect information, to establish the geological profile, identify the nature of the ground, discontinuities, potential hazards, uncertainties, etc. And evaluate, especially for deep tunnels, the risks and probability of rock bursts, convergent, squeezing. And then with this information, it is provided to the designer to design the structures, evaluate the convergences, and define and dimension the provisional support. The designer then evaluates the uncertainties and the risk and defines the most suitable execution methods and evaluates the production rates for the works. The investigation strategy is specific to each project and to the issues encountered depending on the local context. Investigation is a progressive and iterative support process from the preliminary steps to very detailed analysis. And each stage of investigation is defined according to the results of the previous stage, and we are going to see it in a more detailed way later on. It's a long process. It took more than 10 years of investigations for the 3 long alpine tunnels that are more than 50 kilometers long. For less complex projects, it still takes several years. Poor investigations often lead to very difficult or even catastrophic situations during the works, while safety of the workers is our primary concern. Investigations may represent a certain duration, a certain budget. It has to be seen as an investment, not an expense. It's an insurance to master the final cost of the project and to make sure we have the needed finance before starting the works. The main difficulty for investigations is that we can't access from the surface, especially for long and deep tunnels in the mountains. So we need to combine several investigation methods, from the simplest one, geological maps, but okay for the first preliminary stages, not available in all countries, however. Detailed geological surveys, with a specific approach, structural geology, interpretation of aerial photograph or satellite data that nowadays we do with digital interpretation software. Here we have a link with the first presentation of Anthony. New tools can help us speed up this process. Boreholes, but sometimes for deep tunnels it's not competitive given the length of the boreholes. An innovative method that was used for the Montcenis-based tunnel more than 20 years ago is direct drillings coming from the mining industry to reach deep levels. Exploration galleries, as we are going to see, that can be reused during the operation of the tunnel for safety reasons. And temperature measurements, which have an influence on the ventilation required to do the works, and sometimes an impact on the diameter of the final tube. A few words about the Montcenis-based tunnel located on the Lyon-Turin railway project, which is a new railway line to link the Italian and French high-speed networks on 270 kilometers, operated at 220 kilometers per hour. The base tunnel is at the center of this project. And here you have more details on what it is about. It's the main structure of the cross-border section. It's a complex infrastructure with two parallel tubes of nearly 60 kilometers. And for safety reasons during operation, you have 204 cross passages to ensure evacuation in case of emergency of the operation. And there are 4 down adits to allow the access of the rescue teams in case of fire. These 4 down adits were used to assess the research axis that the owner wanted to develop for the main geological obstacles and the most effective solutions for the construction. These 4 adits are first Saint-Martin-la-Porte, about rock convergence. We are going to develop it later on. Another adit to deal with water management in the tunnels. Another about the recovery of the volume of excavated materials, which is quite huge on that kind of project. And the last one for mechanized excavation. So then on this Saint-Martin-la-Porte adit, how did we do from the first investigations to the excavation of the main tunnel? There has been a 20-year-long preliminary investigation campaign during which Egis was advisor of the owner, Telt, together with our partners of Alpina. And we designed, we procured, we followed the works of those investigations. This was a stepped approach. First stage more than 20 years ago with traditional drillings, but also the directed ones, as we mentioned earlier. Here you can see the type of investigations and also the huge quantities that were required. Then a few years later, a second stage with the descending access galleries, already 9 kilometers to be excavated, plus exploration galleries of 8 kilometers. And the final stage, the most recent one, with the excavation with a TBM as an exploration gallery, but in the axis of the final tube serving as the final base tunnel on 9 kilometers, plus another section traditionally excavated on 2 kilometers. Only after those 3 steps, the feasibility of the project was confirmed, which was essential to reduce the risk, to release the financing, and allow the development of safe methods for the excavation of the parallel base tunnel through the same geological formations. I'm not a geologist, but a few words about the geological background. The geology is complex because we are between 2 main formations with limestone on one side, sandstone and schist on the other side, and in between a highly tectonized zone called the front houlier. And this was the crucial part to be recognized through the investigations. After the second stage, the excavation, the investigation galleries, we had a few findings. First, we discovered what was really like this front houlier geological formation. You can see from the differences, if you played a 7 hours game between the two geological sections, what we expected and what was reality when we excavated this gallery. We had quite exceptional difficulties during excavation work. Here you can see on the picture, which was around the world, the high amplitude, around 2 meters convergence phenomenon, while we still had a limited overburdened terrain, 300 meters. On other sections of the tunnel, we reached more than 1,000 meters. And due to this phenomena, we had to design and develop specific systems to control the formations of the terrain and stabilize the structure, and thus guaranteeing the safety of the workers. To prepare the third stage of investigations, we defined numerous goals of these investigations. As you can see on this picture, second stage was on this geological formation of front houlier. Third stage was in the axis of the final tube. So given the different angle, we still had some things to discover in the same geological formation. And on the right side, we began the T-beam excavation. Those two galleries were excavated in parallel. And here you have a list of all the goals that remained after 2 stages of investigations. We still have to verify the geological assumptions, investigate data, acquire experience, determine also the characteristics of the TBMs. Currently, there are several TBMs to excavate the full tunnel. Thanks to this third stage of investigations, we could define the characteristics of those machines and adapt everything, methods, design, etc. And after the third stage, a few discoveries. On the TBM section, we discovered the reality of the excavation rate, which was quite slow due in particular to the faults we encountered, which required TBM stops, quite long ones, 2 times 6 months, and 2 exceptional maintenance due to the fact that the cutting head was damaged by the large block. You can see here a picture of cutting head to be replaced. On the traditional excavated section, still very low rates of excavation, and still this phenomena of convergence, but in a more limited way, up to 70 centimeters, not 2 meters, which is the result of those adaptive support system that was put in place. And after that only, we were able to prepare the works for the main tunnel. A few perspectives, and we come back to risk management. Not all projects are so exceptional as the Mont-Cenis-based tunnel, but on every project, the principles and methods of investigation remain the same, even for more common or shorter tunnels. The strategy and program of an investigation campaign needs to be defined and adapted to 2 things. First, the potential risk of each project and the magnitude of their consequences, but also on the level of risk one, generally the project owner, is willing to take with full knowledge and awareness of the consequences. A campaign, as we pointed out, requires time and sufficient budget. And as we said, it's an investment to master the project final cost, duration, and guarantee the safety of the works and operation later on. Thank you.
Thank you, Vincent. Anyone have a question? So I have the question.
You have one?
Yes. You show us earlier a picture of the convergence. Is it a common or classical phenomena, or?
Yes. In itself, this phenomenon is a classical one. When you excavate a tunnel, the terrain is trying to fill in the hole that you have just created. It's a natural phenomenon. Just usually it takes time. It's a slow process, so you have time to put steel arches before putting concrete, and again to make sure that the workers down don't take the terrain on their head. But here, in the case of Moncenis Base Tunnel, which was quite exceptional, is the amplitude of this phenomenon. Usually, convergences is a few centimeters, the dozens of centimeters. Here, 2 meters, as we can see on the pictures, was quite rare and required to re-excavate the tunnel in a second stage to make sure that we had the final gauge of the tunnel.
If no more question, we conclude. So, from early stages to the delivery final point of a project, projects are becoming more and more complex, and it's demanding more, increasingly requiring more diverse expertise across multiple fields and not only technical. Egis key is delivering today added value to the client, ensuring a successful outcome for both the direct customers and to the end users. So thank you for listening to us today.